Have you ever imagined robots that can kind of think on their feet? Like planning out complex moves, but in real time. Not just like following a set of pre-programmed, routines,
Right.
but actually reacting to stuff that's unexpected.
Yeah.
Like a pro, you know?
Yeah.
That's what we're diving into today.
Cool.
We're really looking at how robots can like handle the unpredictable chaos of the real world.
It is a fascinating challenge.
Yeah.
Because the real world is just full of, infinite possibilities.
Right.
Think about all the tiny little adjustments that you make when you're driving a car, for instance.
Right.
To recreate that in a robot is incredibly complex.
Yeah, it's almost like that feeling of like you're looking at a menu and there's a million options and you're just like overwhelmed. How do we even like begin to like get robots to make smart decisions without getting lost in this sea of possibilities? Well, that's where this powerful algorithm called Spectral Expansion Tree Search comes in.
Okay.
Or SETS.
SETS.
And instead of trying to like map out every single option, SETS kind of like simplifies things.
Okay.
By breaking down a robot's movements into like manageable chunks,
It's a bit like learning a language.
Okay.
Instead of like memorizing every possible sentence that you could ever say, you learn the grammar and the vocabulary, the building blocks.
Yeah.
So SETS does something similar.
Okay.
Figuring out the essential moves that the robot can make, base it on its capabilities and its surroundings.
So it's almost like giving the robot like a toolbox of effective moves rather than like this giant instruction manual, right?
Exactly.
But then how does SETS actually like choose the best moves for a given situation?
Right.
It's not like it can predict the future.
Well, not exactly.
Right.
It uses something called the spectrum of the locally linearized controllability Gramian.
Okay, you've piqued my interest.
Which sounds very intimidating, I know.
Yeah. Break that down for me a little bit.
But it's really not.
Yeah.
So imagine you're a dancer.
Okay.
And you have this wide range of moves from simple steps to, complex leaps and turns.
Yeah.
This Gramian is like a map of your movement potential. It highlights which moves are easy for you to do and which ones require more effort.
So it's analyzing the robot's like strengths and weaknesses for movement, essentially.
Exactly. And then the spectrum part comes in.
Okay.
By analyzing the spectrum of this Gramian, SETS identifies the most meaningful moves for a given situation. It's like figuring out which dance moves will have the biggest impact on the overall performance.
So it's not just about having a wide range of moves.
Right.
It's about choosing the right moves at the right time.
Exactly.
And this is all happening in real time.
Yes.
As the robot is like
in real time
navigating the world.
Yeah.
That's crazy impressive.
It is. And the researchers actually tested this on a variety of different robots with very different challenges. One example, they had a quadcopter drone navigate a complex obstacle course with moving targets.
Wow.
All while battling strong winds.
So it's like almost like a drone playing like a super advanced version of Flappy Bird.
Yes, exactly.
That sounds intense.
It was. And SETS was the key to the drone's success. Because it had to constantly adjust its trajectory to avoid obstacles, reach targets, and account for those gusts of wind.
So even with all that chaos, SETS was able to help the drone stay on course and achieve its goal. It kind of makes me think of self-driving cars.
Yeah.
Because they need that same kind of responsiveness, right?
Absolutely.
To handle unexpected things that are going to happen on the road.
The ability to react in real time is crucial for any autonomous system in the real world. But SETS isn't just about reacting, it's also about anticipating.
Oh, how does it do that?
Well, they also tested SETS on a tracked vehicle with a human driver. Think of it like an AI co-pilot that's constantly analyzing the terrain and looking out for potential hazards.
So like a super smart guardian angel, basically.
Exactly. So even if the human driver makes a mistake, SETS can adjust the vehicle's movements to keep it safe. They tested this on a course with slippery slopes and obstacles and even this narrow chicane track.
Wow.
And SETS was able to handle it all.
This is all sounding incredibly promising, but I have to ask.
Sure.
What about situations where, like, the robot encounters something truly unexpected? Like something it's literally never seen before. Can SETS handle that kind of uncertainty?
That's a great question. And it really gets at the heart of what makes sets so innovative.
Yeah.
It's not just about reacting to the present. It's about learning from experience to handle, future unknowns.
Oh,
remember that tree search we talked about?
Yeah. You mentioned it uses something called Monte Carlo tree search, right?
Exactly.
I've heard of that before in the context of like game-playing AI.
Exactly.
Yeah.
It's this powerful technique that allows sets to like explore different possibilities.
Okay.
Kind of like a chess player thinking several moves ahead.
Yeah.
But instead of just like brute forcing every possible option,
Right.
sets cleverly prioritizes the most promising branches.
Okay.
Based on the robot's spectral moves.
So it's strategically exploring possibilities, not just blindly like trying everything.
Right.
Okay, that makes sense.
Yeah.
Especially in a time-sensitive situation.
Exactly.
But then how does it actually learn from these explorations?
Right.
Does it like store all those scenarios in some kind of giant memory bank?
That's the really elegant part. Sets doesn't need to memorize every single detail.
Oh, yeah.
Instead, it extracts statistical information from these like simulated scenarios, refining its understanding of what works and what doesn't.
Yeah.
It's like a basketball player practicing free throws.
Yeah.
They don't remember every single shot,
Right.
but they develop this feel for the right technique through repetition and feedback.
So with each exploration, sets gets a little bit smarter,
Right.
a little bit better at predicting the consequences of its actions.
Exactly.
It's almost like it's developing intuition, which is kind of mind-blowing for an algorithm.
It is remarkable, isn't it?
Yeah.
And the researchers have actually proven that sets can converge to like near optimal solutions.
Wow.
Even for complex systems that are really difficult to model with traditional methods.
That's impressive.
Yeah.
But let's shift gears for a second and talk about a real-world challenge that's both fascinating and a little bit intimidating: space debris.
Yeah.
You mentioned sets was used to control spacecraft capturing debris.
Yeah.
That sounds straight out of a sci-fi movie.
It does, doesn't it? And the dynamics involved are incredibly complex.
Yeah.
Just imagine two spacecraft tethered together, trying to wrangle a tumbling piece of debris in zero gravity.
I could barely picture that.
Yeah.
How did sets even begin to tackle that problem?
Well, in this case, sets had to coordinate the movements of both spacecraft, using the tether to influence the debris' trajectory.
Okay.
It's almost like this cosmic ballet, with each spacecraft making these precise adjustments to control the motion of the other and ultimately capture the debris.
That's incredible. But all these examples we've discussed involve robots that are like physically interacting with the world. Can sets be applied to problems that are more, well, virtual?
Absolutely. The researchers also tested sets on a simulated glider that was tasked with observing a target while conserving energy to stay aloft. It's similar to how birds use thermals, those rising columns of air, to gain altitude without flapping their wings.
So the glider had to be smart about how it used its energy.
Yes.
Almost like planning a budget for a long trip.
Precisely. And what's amazing is that sets, without being explicitly programmed to do so, figured out that the optimal strategy was to alternate between observing the target and exploiting thermals to gain altitude.
So it essentially discovered the art of soaring.
It did.
Just like a bird.
Just like a bird.
That's remarkable. So it's not just about planning paths.
Right.
It's about understanding the underlying physics and principles of the environment to come up with truly creative solutions.
You've hit the nail on the head. And that's why sets has such huge implications.
Yeah.
Not just for robotics, but for the future of AI in general.
Okay, I'm really intrigued now. You've painted this incredible picture of what sets can do.
Yeah.
But I'm also curious about what it means for me.
Right. For the average person. Yeah. How is this going to change our lives? We've been talking about all these amazing applications. Yeah. Drones navigating wind fields, self-driving cars, anticipating hazards, even spacecraft, like wrangling debris.
Yeah, it's pretty wild.
It's clear that sets has the potential to like revolutionize robotics. But I'm wondering about like the bigger picture here.
Sure.
What does this all mean for the future of AI?
Well, that's the really exciting part. Sets isn't just like a cool piece of tech.
Right.
It represents a fundamental shift in how we think about artificial intelligence.
Okay, I'm all ears. How so?
Well, traditionally, we've programmed robots with very specific rules, like a detailed instruction manual for every situation.
Right.
But sets takes a different approach.
It's more about giving robots the tools to figure things out on their own, right?
Exactly.
Like we've been talking about with the glider learning to soar.
It's about equipping robots with the ability to learn and adapt, rather than just following pre-programmed instructions. So it's not just about making robots smarter. It's about making them more intelligent.
Precisely. And that has profound implications for the kinds of tasks robots can perform and the ways that they can interact with the world.
You know, it's funny. We often talk about AI as this like futuristic concept, but SETS feels like a real step towards making that future a reality.
I agree. We're moving away from robots that simply execute commands to robots that can understand, learn, and even reason about their environment.
And that opens up a whole new world of possibilities, doesn't it?
It does.
I mean, if robots can learn to soar like birds, what else could they learn to do?
That's the question, isn't it? We're really just scratching the surface of what's possible with this technology.
It's both exciting and a little bit daunting to think about where this could all lead.
I think that's a natural reaction to any truly groundbreaking technology.
Right.
But ultimately, I believe this kind of intelligent automation has the potential to make our lives easier, safer, and more fulfilling.
I like that perspective. So as we wrap up our deep dive into SETS, what's like the one takeaway message you want our listeners to walk away with?
SETS is a powerful reminder that the future of AI isn't just about building machines that can think like us. But machines that can learn and adapt alongside us. Pushing the boundaries of what's possible.
Beautifully said.
Okay.
And to our listeners, we leave you with this thought-provoking question.
Okay.
As robots become more intelligent and adaptable, how will our relationship with technology evolve? Thanks for joining us on this deep dive into the world of robot planning. And until next time, keep exploring.